Hello, David Kenworthy here. It's the 24th of the 7th, 2021, and we're going to look at the Great Giza Pyramid in the context of the new metrology. And what is the new metrology? Named units are variables, but the ratios between the units are fixed. This is a completely different way of investigating historical metrology. It's never been done this way before. So what we've got are the named units: the meter, the yard, the megalithic yard, the geodetic cubit, the Riemann, the foot, the ancient foot, the digit. We've got the Giza base in inches, the Giza base in feet, the Giza base in digits, and the Earth's circumference in miles. And the Earth's circumference, in inches as well. So we multiply the mile by 63360. So what we're saying is that the meter is a variable unit of measure, and everything can be derived, all the other units can be derived from the length of the meter. So the ratio that determines the other units is here. So we can see that the yard is the meter divided by 1.1. The megalithic yard is the meter divided by 1.2. The geodetic cubit is the meter divided by 1.9008. The Riemann is the meter divided by 2.7. The foot is the meter divided by 3.3. The ancient foot is the meter divided by 3.375. And the digit, Berriman tells us, is the meter divided by 54. And the number of digits in each unit can be worked out, because once we've calculated the actual length in inches of each unit, we can divide digits into it and get this fixed set of numbers here. So if we change the meter, let's change it to Berriman's 39.375. We can see that the ratio stays the same. This is a variable unit. All these other units change, but the digits stay the same. So the variables are the units themselves. The distance between each unit, that's this line here, that is constant. And that's the difference between the new metrology and existing metrology, where there are no modern metrologists that have realized that this is the way that the system was set up by the ancient designers. So when they're talking about the cubit that we have to find to know how Giza was designed and built, that's nonsense, because there's no one specific cubit in the design of the Giza pyramid. There are many different cubit lengths, and the constant is the number of cubits in the base length wherever the base is. So it's height dependent. So if the height of the Giza pyramid is at its maximum, we'll have a base length when the meter is 39.6. The base length is 366.666 recurring inches, and that's the base length determined by Colonel Vise. Now, if the base length is 352 inches, we're going to have a meter of 39.6 divided by 366.666 times 352. I'll have to put a plus in there at the start. I need to put a few more sixes in there. And now we have 35200, and the meter is 38.016, and the cubit is 20 inches. So although the meter looks a strange length in inches, the cubit to give us that base is exactly 20 inches. And look at the megalithic yard, 31.68 inches. The yard, 34.56. The Riemann, 14.08. The foot, 11.52. And the digit, 0.704. Giving us 35200 inches in the Giza base. 2933.333 feet. And we know that the eclipse month is 29.333 days. We've been through that on another presentation. So let's go back to 39.6. And now we're going to look at the megalithic yard, which is this line in yellow. Now the reason why the megalithic yard is so important in the Giza design is because it was discovered there by Hugh Franklin. He worked out that there are exactly 1111.111 recurring megalithic yards in the Giza base, always. So if we divide this number here by this number, we're going to get the number of megalithic yards in the Giza base. So let's just look at what it is. That's a constant. Let's have a look at the cubit. That's a constant. 1760. We know there's 1760 cubits in the Giza base. And we know there's this number of megalithic yards because Hugh Franklin told us in his analysis that that is always there. And we know from that that there's a ratio between these two numbers. So if we divide that by that, get 1.584, exactly what Hugh Franklin told us. And there's great complexity here because this ratio, these ratios are designed for specific reasons, and we can't go into them now because it's too complicated. But just look how complicated this table is. And we're going to look at the megalithic yard now. What effect does putting in the meter that gives us the megalithic yard in there, what effect does it have on the Giza base? Because this model now is going to answer questions. I know what the meter is that goes with the megalithic yard. So I put it in. There's the megalithic yard. There's a 2.72 feet. Still 45 digits. Still a ratio of 1.2. What we find now is that the meter in feet is 3.264. So inches divided by 10 gives a metre in feet. So the megalithic yard divided by 10 when it's in inches gives a metre in feet. So let's do it for 39.6. 33 inches, 3.3 feet. It's a constant ratio. And now we can see that the megalithic yard is a very simple unit. It's a constant ratio where when the meter is a variable unit, the length of the meter determines the length of the megalithic yard. So we know that the base 100 meter, which is 39.6 inches, is giving us 366, this vise base. And what happens when we put the megalithic yard meter? It's an exactly 400 inch difference. So the megalithic yard is designed, when it's actually used at Giza, it gives us a 400 inch difference in the base 100 base length determined by Vise. So it's giving us 100 inches off each side, which is an ancient meter, a Giza meter. And I've already been through that in different presentations. So lots of questions are being asked by this model. They're being asked about our modern metrologists who've told us that they've uncovered the design of the Giza pyramid. And the way they've done it is they've worked out that the cubit is a base 12 cubit. And we can actually put the cubit in because we know what the meter is that relates to the base 12 cubit. So we choose this cell here and we put divided by 25. That's the Earth's circumference, base 100. And that's the Earth's circumference using the base 12 cubit. And there is the base 12 cubit, the geodetic cubit, 20.736. Another question answered. Is this system that Michelle and John Neal have worked out, and they're telling us this is the system that everything's derived from, is that right? Answer, no, it isn't. It's not producing the base 100 system. It's producing 1.728, we're expecting that. But the foot is only 0.995328 of 12 inches. And we want the Giza pyramid to be designed against a foot of 12 inches. So we have to put 39.6 in there. So this model is starting to answer questions. How many meters are there in the Giza base? It's 50,000 divided by 54. How many yards are there? Now, we've calculated the megalithic yard as D18 divided by D12. D18 divided by D12. But we can calculate it using digits because there are 50,000 and there should be 50,000 divided by 45, and that should be the same as that. Another question answered. We can do the same. We can do the same for the cubit. So 50,000, we've got D18 divided by D13, but 50,000 divided by that should be the same. Another question answered. The Riemann is 20 digits. How many Riemann in the GP base is very obvious. How many modern feet? Another question answered. There it is. It's the same. We're working this out correctly using Colonel Visor's measure. How many ancient feet in the Giza base? Another question answered. 3.125 is Babylonian pi. And how many digits are there in the Giza base? Of course, 50,000. That's the new metrology. Completely different from the current state of metrology. And we can't reconcile anything at all using modern existing metrology. But using the new metrology, everything can be reconciled. Because it's all taken from the book Historical Metrology by Algernon Berriman, published in 1953. Everything reconciles in that book, and that's what I've used to create the new metrology, which really is just Algernon Berriman's metrology. So that's it for now. Thank you.